Welcome to this training module on designing overall AI strategies for business solutions. Today, we are going to focus entirely on architecting multi-agent solutions using Microsoft platforms. Welcome, everyone. Let's start with the what. What exactly is a multi-agent solution? Imagine you have a massive, complex business process. Instead of building one giant, monolithic AI agent to handle every single task, which can become incredibly difficult to manage and prone to errors, we decompose those responsibilities. We break them down across specialized AI agents. This is the core of multi-agent architecture. Think of it like a team of experts, where each agent has a specific role, a specific toolset, and a specific scope of data it can access. As you can see in the bullet points, the basics involve establishing clear boundaries. We do this because it enforces a strict separation of concerns. If the finance team needs a specific workflow, their agent handles it without tangling with the HR agent. How does this work in practice? We use orchestration frameworks that manage the state and seamlessly hand off tasks between these AI colleagues. Diving deeper, this represents a fundamental shift in AI strategy. We are moving from single, generalized AI models to a distributed network of AI microservices that communicate securely. Let's take a look at the diagram on your screen. It perfectly illustrates this concept. On the far left, we start with the user request. This is the initial prompt or trigger. This request flows into the orchestrator agent, represented by the central node. The orchestrator acts as the team leader. Instead of doing the work itself, it evaluates the request and routes it to the specialized agents. You can see the arrows branching out to Agent 1 for finance, Agent 2 for HR, and Agent 3 for operations. Each of these nodes represents a distinct, isolated AI entity with its own set of instructions and knowledge bases. Finally, once the specialized agents complete their tasks, the arrows converge back to deliver a unified result to the user. This visual flow demonstrates the power of decomposing tasks. It's simple, scalable, and highly efficient. If one agent needs an update, the others remain unaffected. Moving on, we need to answer the why and the when. Why should you choose a multi-agent architecture over a simpler single-agent design? The golden rule here is to start simple and scale only when the evidence requires it. A single agent consolidates logic and reduces overhead. However, as our first bullet point highlights, you must shift to a multi-agent approach when you need to cross strict security or compliance boundaries. For example, if one process handles public data and another handles highly confidential employee records, they must be separated. Another why is organizational structure. If multiple teams own distinct data and have different release cycles, decoupled agents prevent bottlenecks. So, when exactly do you pivot if your strategic roadmap demands future expansion across 3, 4, or 5+ distinct business functions? Modularity is essential to avoid massive refactoring later. But let's dive deeper into the trade-offs. Multi-agent systems aren't free of challenges. They introduce added orchestration complexity, they can introduce latency during agent handoffs, and they expand your security surface area. You must weigh these costs against the benefits of scalability. Direct your attention to the flowchart, which serves as a decision-making tree for your architecture. It starts at the top with a critical question: what is the complexity driver? We have 3 distinct pathways here. Following the left arrow, if your driver involves strict security boundaries, the flow dictates you choose a multi-agent system. Similarly, following the middle arrow, if you have distinct teams or data silos, you again land on the multi-agent approach. Both of these converge at the bottom node, highlighting the ultimate benefit: scale and isolate. But look at the right pathway. If your use case is bounded and simple, the flow directs you to a single agent architecture, which leads to the outcome of low latency and lower cost. This diagram is a fantastic mental model. Whenever you are proposing an AI solution, walk your stakeholders through this exact flowchart to justify why a multi-agent system is or isn't the right choice for their specific business problem. Now that we know why we need multiple agents, how do we actually build them? This brings us to the Microsoft AI platform ecosystem. To design a multi-agent solution effectively, your main focus must be on leveraging the right platforms: Microsoft 365 Copilot, Copilot Studio, and Microsoft Foundry. As outlined in the basics, these are our 3 primary engines. Why do we have 3? Because aligning the right platform to a specific agent's role optimizes both your cost and your development time. We don't want to write custom code for a simple task, nor do we want to force a low-code tool to run a highly complex enterprise orchestration. How do we apply them? We use Microsoft 365 Copilot, which is SaaS, to activate immediate value within the flow of work. We use Copilot Studio, our low-code SaaS option, for rapid iteration on business workflows. And we use Microsoft Foundry, our pro-code pass, for complex integrations and custom evaluations. Diving deeper, a true multi-agent solution often mixes these platforms. You might have a Foundry orchestrator delegating tasks to a Copilot Studio agent. It's all about platform role mapping. Let's review this bottom-up diagram to visualize the ecosystem. At the foundation, we have three distinct pillars representing our platforms. On the left, we have Microsoft 365 Copilot, our SaaS offering. In the middle, Copilot Studio, our low-code engine. On the right, Microsoft Foundry, our pro-code environment. Notice how the arrows from all three of these pillars flow upward into the central node, the multi-agent ecosystem. This illustrates that a multi-agent architecture is not restricted to a single tool. Instead, it acts as a container that can orchestrate agents built across different platforms. Finally, that ecosystem flows up to the ultimate goal, a unified business solution. By looking at this diagram, learners can easily perceive that flexibility is built into the architecture. You can mix and match these platforms based on the specific requirements of each individual agent within your broader AI strategy. Let's zoom in on the first two platforms, Microsoft 365 Copilot and Copilot Studio. What are these best used for in our multi-agent architecture? M365 Copilot is your domain assistant for personal and team productivity summarizing, drafting, and scheduling right where users already work. Copilot Studio, on the other hand, is for building business workflow agents. The basics here are simple. M365 handles the everyday productivity, while Studio handles tailored, specific business processes. Why rely on these? Because they offer rapid iteration. Copilot Studio comes with pre-built connectors and out-of-the-box responsible AI guardrails, meaning you can deploy safely and quickly. How do we do it? We connect Studio agents to enterprise data using Power Platform connectors, turning them into highly effective retrieval or task agents. In a deep dive context, Copilot Studio is perfect for creating specialized subagents. If you have a massive Foundry orchestrator, it can hand off tasks to a Studio agent that was built by a business analyst who understands the specific domain logic. It's about empowering the right people with the right tools. Looking at this diagram, we see the practical interaction between the user and these platforms. At the top, the user interacts directly with the Microsoft 365 Copilot interface. This is their primary entry point. From there, M365 Copilot can immediately pull context from Word or Excel, as shown by the arrow pointing to the bottom right. But notice the dotted arrow pointing to the Copilot Studio agent. This represents delegation. When a task requires specific business logic like updating a CRM record, M365 Copilot delegates it to the specialized Studio agent. The Studio agent then interacts securely with enterprise data, labeled here as Dataverse/CRM, and executes an automated action. This visual clearly maps out how a SaaS productivity tool and a low-code workflow tool collaborate seamlessly to extend the user's capabilities without forcing them to leave their primary workspace. Now, let's explore the heavy lifter, Microsoft Foundry. What is it? Foundry is our pro-code platform designed for complex integrations, custom AI models, and sophisticated multi-agent orchestration. The basics of Foundry revolve around control. Unlike SaaS or low-code options, Foundry gives your developers full control over the underlying language models, the specific tools utilized, and the runtime execution environment. Why do we need this? It is absolutely essential for strategic, high-integration scenarios where standard connectors aren't enough, or where you need to run custom evaluation pipelines to ensure compliance. How do we utilize it? Developers use the Microsoft Agent Framework SDK within Foundry to build and connect these agents programmatically. Diving deeper, in a multi-agent solution, Foundry is typically where you build your primary orchestrator agent. This orchestrator manages the complex logic, maintains the state of the conversation, and securely manages the handoffs to other specialized agents. If you need a truly autonomous, enterprise-wide AI nervous system, Foundry is where you build the brain. This flowchart strips down the architecture of a Foundry-based solution. The large node on the left is the Foundry orchestrator. This is our pro-code mastermind. The arrows labeled SDK handoff show the orchestrator directing tasks to Custom Agent 1 and Custom Agent 2. Because this is built in Foundry, these subagents can connect to highly specific, secure backend systems. Agent 1 connects to custom tools and APIs, while Agent 2 connects directly to enterprise databases. Finally, notice the arrow pointing down from the orchestrator to the evaluation pipeline. This is a critical feature of Foundry, the ability to run continuous, programmatic evaluations on the orchestrator's decisions to ensure safety and accuracy. This diagram highlights the power, control, and enterprise readiness that a code-first approach provides in a multi-agent setup. Understanding the platforms is just step one. Next, we must define how agents collaborate through orchestration patterns. What are these? They're explicit blueprints: sequential, concurrent, and Agentic for managing how multiple agents work together. The absolute basic rule here is to avoid ad hoc, prompt-to-prompt daisy chains. They are brittle and hard to troubleshoot. Instead, we use structured patterns from the Agent Framework SDK. Why? Because structured orchestration ensures reliability, traceability, and deterministic execution of tasks. How do we apply them? We use sequential orchestration for a strict step-by-step pipeline, like plan, then enrich, then verify. We use concurrent orchestration when agents can tackle independent subtasks in parallel to save time. Let's do a deep dive on the Agentic pattern. Think of Agentic orchestration as a literal magnet. You have a central orchestrator that dynamically evaluates a user's request at runtime and only pulls in the specific expert agents needed for that exact task. It's highly efficient and highly dynamic. Let's focus on the Agentic pattern shown in this diagram. Inside the boundary box, we have the orchestrator node sitting centrally at the top. Below it are our specialized agents, Expert A, Expert B, and Expert C. Notice the dotted arrows labeled pulls in if needed. This is the magic of the Agentic pattern. The orchestrator doesn't automatically send data to all agents. Instead, it evaluates the context of the current task. If the task only requires the skills of Expert B, the orchestrator acts like a magnet, dynamically pulling Expert B into the workflow, while leaving A and C alone. This visual helps learners easily perceive how dynamic orchestration conserves compute resources and ensures that only the most qualified agent handles a specific piece of the workload. Now we move to the practical application, designing the connected agent workflow. What is this? It is the systematic, step-by-step process of architecting your multi-agent solution from the ground up. As you can see in the basics, the process is structured. First, you define your main orchestrator agent. Next, you identify the specific roles for your sub-agents like researcher, planner, or reviewer. Then, you model the collaboration using the patterns we just discussed, build a prototype, and iterate. Why follow this rigid process? It prevents architectural drift and ensures that every single agent has one clear, single responsibility. How do we execute this? By defining explicit interface contracts and managing state handoffs carefully. For example, agents should pass record IDs rather than massive blocks of raw data. Diving deeper into the iteration phase, a key practice is pruning redundant agents. As you test, if evidence shows that a single agent can handle two roles effectively without breaching security, you consolidate them. Optimization is an ongoing process. This sequence diagram illustrates the lifecycle of a task within our connected workflow. It reads from top to bottom. First, the user submits a task to the main agent. The main agent then performs internal logic to determine which specialized role is needed. Once decided, it executes a handoff to the sub-agent. Note the label here, pass context ID. As we discussed, we pass minimal, hygienic data. The sub-agent then executes its single responsibility in isolation. Once complete, the sub-agent returns the result back to the main agent. Finally, the main agent synthesizes this information and delivers the final output to the user. This diagram makes it incredibly easy to perceive the clean, isolated interactions between agents, proving why clear interface contracts are so vital to the design. We conclude our training with the most critical aspect of any AI strategy: security, governance, and observability. What are these? These are the non-negotiable operational guardrails for your multi-agent systems. The basics involve enforcing least privilege access, maintaining context hygiene, and comprehensive logging. Why is this so important? Because when you decompose a system into multiple agents, you inherently increase your security surface area. More agents mean more potential points of failure or data leakage. How do we secure this? We scope credentials incredibly narrowly. An HR agent should absolutely never have access to finance databases. Furthermore, we mandate human-in-the-loop approvals for any high-risk actions before an agent can execute them. Diving deeper into observability, you must instrument and monitor the system meticulously. You need to track handoff latency between agents and monitor tool failure rates. If one subagent goes down, the orchestrator must be designed for graceful degradation, informing the user of the delay rather than crashing the entire system. Our final diagram illustrates the protective wrapper around our multi-agent solution, the governance boundary. Inside this green box, we have our core operational pillars: agent operations, identity and access, and observability logs. Below, we have our active subagents. Follow the dotted lines. Both agents must authenticate through the identity and access node using least privilege protocols. They only get exactly what they need. Simultaneously, the thick arrows show that every action these agents take generates telemetry that feeds directly into our observability logs. Finally, the Agent Ops node at the top left maintains active connections to the agents, allowing administrators to monitor performance and instantly initiate rollbacks or interventions if an agent misbehaves. This visual perfectly encapsulates how we secure and govern a scalable, multi-agent AI ecosystem.